Hello, my name is Ankush Sharma and my registration number is 23BPS1151 and my topic is modern computing devices and Turing machines. Computing devices. Computing devices are machines designed to process data and perform calculations according to a set of instructions or program. These devices range from basic calculators to highly complex systems like modern computers and smartphones. They execute tasks by following algorithm, manipulating binary data to solve problems, run applications, and manage digital information. Traditional computing devices, including desktops, laptops, and servers, while more specialized ones encompasses embedded systems in appliances, automotive computers, and wearable. Modern advancements have led to powerful variations such as quantum computers and supercomputers. Now we now I tell about you types of computing devices. There are many types of computing devices like personal computers, mobile devices, servers, embedded systems, and supercomputers. Personal computers are these include desktops, laptops, and used for general purpose tasks such as browsing, productivity, gaming, and mobile devices like smartphones and tablets are portable devices designed for communications, internet access, and app-based tasks, touch interface, and mobile operating system. Server Servers are powerful computer that stores the data that computers made and mobile made. Embedded systems, small computing system embedded with larger devices like appliances, cars, and industrial machine used to control specific functions. And supercomputers, extremely powerful systems used for computations, specific research, climate modeling. How can we use personal computers in the theory of computations? Let the applications, like in the theory of computation, a personal computer serves as a practical tool for exploring and applying theoretical concepts. Like first is automata and Turing machine simulations. PC can run program to simulate finite automata, push down automata, and Turing machines, making abstract model can't make interactions in whiteboard or blackboard, but using the simulations we can explain better way to students. Second is algorithm implementations. So PCs allow testing of algorithm in real world applications, examining their corrections and efficiency. Third is formal language processing. PCs can process strings, implement regular expression, and parse context-free grammars, supporting studies of language models in TOC. Next is complexity analysis. PCs help researchers simulate the time and space complexity of algorithms. Aiding is the study of computational complexity theory. Now I tell you about the mobile devices applications in TOC. In the theory of computation, mobile devices serves as accessible platform to experiment with and apply theoretical concept, particular in real world and portable contexts. Mobile devices extend this field several ways, like automata simulation apps. Mobile apps can simulate finite automata, push down automata, and Turing machines provide interactive learning experiences. Next is algorithm practice and complexity analysis. Mobile devices support running algorithm and analyze their performances, helping user experiment with algorithmic efficiency. Third is language processing and regular expression. Many mobile applications use regular expression for input, validation, search function, and text processing, making TOC concept applicable in mobile app. Mobile machine learning models. Lightweight machine learning models on mobile devices often utilize TOC principles. Now this image shows you the mobile app development process. Like image of mobile. Okay, like the first we plan, then we design, then we develop app by coding, then we test, then we deploy. So that's the whole process of developing an app. Now the supercomputer applications in TOC. In theory of computation, supercomputers are valuable for addressing complex computational problems that require high processing power and speed. They enable deeper exploration of TOC concept in practical. Complex theory studies, like complexity theory studies, simulation of advanced automata and models, quantum computing and research. Supercomputers allows testing and analysis of time and space complexity for algorithms that are too computational intensive for regular components. Simulation of advanced automata and models, Supercomputers can simulate large-scale automata, including advanced models of millions of states. And quantum computing research. They support simulation of quantum algorithms and automata, bridging classical TOC with emerging quantum computations. Now I tell you about what is a Turing machine exactly. A Turing machine is a theoretical model of computation introduced by Alan Turing in 1936, designed to mathematically represent a machine. And it's often used in theory of computation to define that you know already. Now I tell you about key components of Turing machine. So there are four key components in a Turing machine, that is tape, head, state register, transition function. So what a tape do is an infinitely long tape divided into cells where each cell hold a symbol from finite alphabet, and the tape serves as both the input and the memory of the machine. Okay. Head, a head is like the machine has a read write head that moves left or right along the tap, reading symbols and writing new ones based on the machine rules. So tape, so like tape is just like the sections, and the head is like a moving thing that read left and right symbols of that. And state register, that state register keep the current states track, and the transition function a set of rules that dictate machine action based on current state and symbol state. And transition function which tell you about what state should be next based on the current state and symbol under the head. So there is steps for that, write a symbol on the steps, move. Okay, now working of it. Now I tell you about working of Turing machines. Turing machines begins on an initial state with an input written on a tape. It reads, writes, moves and changes states according to its transition function. The machine continues this process until it reaches the halting state, which significantly has completed computations. Now importance of Turing machines. Like the importance of Turing machine is in model of computations, decidability and undecidability, universal computations. Turing machine serves as foundation of computational theory, defining what it means to be computable and exploring boundaries of arithmetic problem solving. Like in model of computation, Turing machine represent a fundamental model of computation, showing the limit what can and cannot be computed, and it helps us to classify problem that's decidable, which is decidable or not decidable. And universal Turing machine can simulate any other Turing machine form basis on modern computers and programming. Like what is the use of Turing machine in the real life? In the real life, the importance of Turing machine is the concept of Turing machine had profound impact on real life computing, like foundation of modern computing, define computability and developing a programming language. Turing work on symbolic processes led to the development of programming language, the concept of universe machine, and they can simulate any other machine's form. And for like basis of algorithmic design, Turing machines formalize what it means to perform step-by-step processing of data, forming the backbone of algorithm design and complexity theory. This helps us to design efficient algorithm. Like now Turing machines most powerful model of computations. There are some model of computations in Turing machine like universality, infinite memory, unrestricted read-write capabilities, ability to define computability, versatile state transitions, complexity analysis, and complexity theory. In universality, the Turing machine can simulate any other computational device, including finite automata and push-down automata, as well as complex algorithm and programming language. This concept is embodied in the universal Turing machine. Infinite memory tape. Unlike other automata with finite memory, a Turing machine has an infinite tape, allowing it to handle computation required unbounded memory. And in unrestricted read and write capabilities, the Turing machine's read-write head can move left or right across the tape to modify any cell. And in ability to define computability, Turing machines are used to define the limits of what is computable. They establish the boundary between decidable and undecidable, as we discussed before. Versatile state transition. Turing machine have a flexible transition function that allows them to take decision based on both the current state and input symbol. And like In complexity analysis, Turing machine form the basis of complexity theory, which classify problems by the time and space resource they require. Now, like, what is the difference between the Turing machine and the modern computing devices we use today? Like, in the aspect of memory and resources, Turing machine has an infinite tape of memory, theoretically providing unlimited storage. In modern computers have finite memory determined physical hardware, RAM and hard drives, etc. In the aspect of processing power and speed, Turing machine operates sequentially without regard speed designed to demonstrate functionally. In modern computers, process data at high speeds, leveraging parallel processing for rapid operations. In determinism and practically, a purely deterministic model, impractical for, and in modern computers use both deterministic and non-deterministic process. Real world application but valuable, and then modern compute we can use in multitasking. Purpose and applications of Turing machine are like a theoretical model defining computability boundaries of essential for TOC, and in modern computer designed for practical problem solving across various domains. And like flexible in instructions, operates on fixed set of rules and does not adapt execute a predefined instructions. And in modern computers run adaptive algorithm and evolving software handling dynamic and interactive tasks. Now the question comes, uh, which is better, a Turing machine or a modern computing device? Like in the practicality versus theoretically, advantage designed for practical applications, uh, uh, designed क्या लिखा है भाई? Like as we talk about the advantage of modern computing devices designed for practical applications, modern computers can solve real world problems efficiently. They're built to handle large data sets, perform complex calculations quickly, and provide user friendly interfaces for interaction. And the limitations of modern computing devices that they are constrained by finite resources and depend on software that must be carefully designed to avoid issues like infinite loops. And in Turing machines, the advantages are the serve as a theoretical foundation for understanding computations. They provide insight into what problems are computable and help classify a problem based on their computational complexity. And the limitations are Turing machines are abstract and impractical for real world tasks. They cannot directly perform tasks like data processing or user interfaces. Now, computational capabilities of modern computing devices. The advantages are like capable of executing algorithm and high speeds at modern devices, and a limitation they are limited to solve problems that are can be computed within the resource constraint. 20. Third point is the flexibility and adaptability of modern computing devices. The advantages are support various programming and paradigms and can run adaptive algorithm enabling them to learn and adjust new informations. Limitations: while they can adapt, they still require careful design and tuning by programmers to optimize performances and prevent errors. And the Turing machine's advantages are they are fixed rules allow for precise definitions of computation, but they lack the ability to adapt the learn from their environment. And computational capabilities of a Turing machine is the theoretically can address any computable problem in given infinite time and memory. But in practical terms, Turing machine cannot execute tasks or provide solution due to their sequential processing nature and reliance on the infinite tape. In the final conclusion is that, in summary, uh, like the modern computing devices excel in practical applications, offering efficiency and real world problem solving through advanced hardware and software. Meanwhile, Turing machines play a key role in theoretical studies, helping define the boundaries of computation and complexity. Together, they serve complementary roles. Turing machine as a foundation model, and modern devices as practical tools for real world computation. Now I given the citations and references to these, and thank you for giving me the opportunity for making this project.